Yeah, hello guys. So welcome to this task, the 0S00C programming hello world task. Okay. In this video, I will walk us through these tasks from the quiz questions all the way to the advanced questions. I will try and be fast. I have already done a video explaining to us the little concept about C or basic concept about C that we're going to be facing in this task. So you'll be expecting another video as other tasks will be released to us. All right, so in today's video, we'll be starting from the quiz question. The question number 1 says, in which category belongs the C programming language? Of course, it's compiled language. So if you go through my introduction to C programming, you should know already it's compiled language. What is a common extension for a C source file? Is .c. So each C program must end with .c, hello.c, hi.c. Which of the following are both valid comment syntax for ANSI and Betty compliance? Of course, this and this for single comments and for nested comment, single comment and nested comment. Which command can be used to compile a C source file? Of course, the GNU GCC compiler. What is the common extension for a C header file? A C header file ends with .h, stdio.h, unistd.h, and all that. What are the different steps to form an executable file for C source code? So like I said, if you've gone through my video, I also explained this, the preprocessor, the compiler, the assembler, and the linker. So this is the correct one: preprocessing state, compilation, assembling, and linking. All right, so let's go to our task. Like I said I'm going to be very fast. So the first thing you need to do is to create a GitHub repository, and the name of the GitHub repository is ALS Low Level Programming. So you have to go to your GitHub account and create a GitHub repository, a public GitHub repository without README, with no ignore, without no ignore. So just your GitHub name and description, and that is all. Now once you've done that, you will need to clone that repository to your terminal. So I will just clone my repository. Let me get a sandbox. I'll clone my repository, and then I'll walk us through the task. Now before then, let's go through the requirements of today's task. Let's go through the requirements. So requirements: allow editor via vim emas. All your files should be compiled in Ubuntu using the GCC and this. All your files should end with a new line, a readme at the root of the repo, and a readme at the root of the project directory. There should be no errors or no warnings during the compilation. You are not allowed to use system. Your code should use the Betty style. Or allowed editors this: all your scripts should be tested on Ubuntu. All your scripts should be exactly this, 2 lines. All your files should end with a new line. The first file should just be this. More info. Betty linter. To run the Betty linter just with command. To run the Betty linter just with command, Betty, then file name. So go to Betty repository, clone the repository to your local machine, cd into the repository, into the directory, install the linter with sudo this, emas or via a new file called Betty, and copy the script below. Okay, once saved, exit and change permission to apply to all users with this. move the Betty file into bin directory somewhere else in your system. Okay. Okay. So for the Sandbox is already pre-installed, but if you are using your local machine, I'm just going to show you how you will do that if you are using your local machine. So before then, I already created my GitHub repository, so I will just clone it. So I'm going to say git clone https, then I will paste my token at github.com / my username / the name of the repository, which is ALS low level. Let me be sure of the name. Let me just copy the name to avoid errors. Okay. Okay, so I will just paste the name of the repository here, .git. So if I got all the spellings correctly, that should be fine. So let's see. Okay. So I have cloned into this repository. So if I ls now, we should see that I have ALS low-level programming language. Now, why it didn't show that you appear to have cloned into an empty repository is because the repository is not empty. All right. So now the next thing I need to do is to cd into this repository, which is ALS low-level programming language. Now, when I cd into this repository, the next thing I will need to do, now I'm inside this repository, the next thing I will need to do is to create a readme.md. So I'm going to say echo, and then I will just say my hello world C program, something like that. And greater than sign, and I will say readme.md. So tap enter to create your readme.md. Now once that is done, after creating your readme.md, you are going to now create a directory, which is 0s00 hello world. So copy your directory, go to your file, and from here, after creating your readme.md, you are going to do mkdir, and then you paste the name of your directory here, and you create a directory which is hello world. All right. Now, just after creating a directory, so I'm not creating it because I already have them in this file, like I said. After doing that, you're going to do cd into the directory you just created, because that's where you're going to be working from. All right, and enter. So now you are inside the new directory you have created. So remember, the first thing you did was to clone your repository, and then after cloning, you create your readme.md file, and after that you create your directory, which is 0s00 hello world, and after creating it, you cd into it, and when you cd into it, go ahead and create your readme.md, which is echo, and then with the whatever you want to give it as the information, you can say my readme, whatever you want to give it, single quote and greater than sign, and then you say readme.md and enter. So now you have succeeded in creating your readme.md, you have succeeded in creating your readme.md in the root of your program and in the root of the repository. So the next thing we need to do is to go, so if you're using your external terminal, then you need to go and install your Betty. I will show you how to do that. Now, because already we have Betty in this machine, so if we do Betty space, let me just say the name of the file and enter, you will see that Betty doesn't have a problem. But if there is no Betty pre-installed in your machine, if you do Betty, you'll see that Betty will give you error. For instance, if I do Betty here, let's clear this. If I do Betty here, so let me just say Betty, and I say Sunday, this is an external terminal, you will see that Betty command not found. Okay. But so if you're using your external terminal, then you have to install Betty. And for you to do that, don't forget you have to CD back to the root of your program. You can just CD back to root. All right, you can CD back to root. And from here, let's go and see how we can install our Betty. So Betty, so now they say to run Betty, go to Betty repository. So let's open Betty repository and see. And then they say clone the repository to your local terminal. So let's see how we can clone this repository into our local terminal. Okay. So this is Betty repository. So we want to clone it into our terminal. All right. So we are going to clone this repository into our terminal. I'm trying to see run the following code to check if your code or the Betty style is this. To run the script, install this sudo privilege this. Okay. All right. So I will go ahead and clone this repository into my terminal. So let me see if this is work directly without doing anything. So if I say git clone, so I just want to try this. If it doesn't work, then we need to use our token. So enter. Cloning into Betty. So we have cloned into Betty. All right. So that worked. So just copy the file, go to code, copy the file, and you are able to clone it. So just type git clone and paste your code. So you're able to clone. That is if you are using your local terminal. So the next thing we need to do, they say, after cloning, they say cd into the Betty directory, install the linter. Okay. So here you cd into Betty. So you're just going to say Betty cd, yeah, so I say, okay, let me ls to see if there's no Betty here. There's Betty. Oh, capital B, cd to Betty. Okay, so now we are in our Betty repository. The next thing you need to do now is to install the linter by using this command. So you just copy this command and paste. All right, copy this command and paste. It's already installed in this terminal, so maybe I should use this terminal and see if it will work with this. So I'm just going to say cd, git clone space, then I will paste this and enter. Okay, so it has cloned. So let's cd to Betty. So now we're in the Betty repository. Now let's go and copy this command to install Betty SSH. So paste Okay, so it says command not found. Let me do this. So let me use SU and C. Okay, so for this particular batch, it's not working. You can try it in your Ubuntu. I already did that with my Ubuntu, so my Betty is already working in my Ubuntu. I have not tried this, but you can try with your Ubuntu and see. Of course, it will work. So if I do Betty now and call a file name, let me see the files I have here. Okay, so if I say Betty and I say hello.c, you see that it will respond because Betty is already installed. But if Betty is not installed, it will say command not found. Let me see, what did it say? It says, okay, that's because I use capital letter. So here is supposed to be small letter, hello.c. So you see that it has responded. It has responded, telling us, there are errors in this file and all that. Okay, so but that is how you can install your Betty linter. And once that is done, let's say the next stage is that you should create a file called Betty. So you're going to do vi. So you do vi. So vi, and then you paste this and enter. So here I'm just going to, I want to set paste because we need to paste and enter. Okay, so here they said and copy the script below. So this is the script we're supposed to copy. This. So you copy this script and then we'll paste it in this file here. Okay, so once you paste it, you can save and exit. Now when you save and exit, the next thing you need to do is to make it executable using this command. So chmod, just copy this and paste and hit enter, and after that you move it to your bin. How do you move it? Use this command, sudo mv betty /bin. So once you do that, your Betty has been installed in your system. All right, I've already spent a lot of time here, so let's move on to our task. So that is how you can install Betty. Let's move on to our task very quickly. So what I'm going to do now is to clear the screen first. Okay. Okay, where was I before? Because I'm already in the root folder. Okay, let me just pick a new sandbox. So I'm using sandbox because I can actually use my Ubuntu. So let me use my Ubuntu so let me just cd to ALS low level. Okay, and then let me clear. All right, so the first question here is a script. So the script says that write a script that compiles a C file but does not link. So like I said in my introduction to C programming, I already explained all this. Write a script that compiles a C file. So it only compiles but does not link the file. The C file name will be saved in the variable C file. The output file should be named the same as the C file, with the extension -o. Okay, this is question 1. This is question 0. Question 0, write a script that runs a C file through the preprocessor and save the result into another file. All right, so the C file, this is the name, and then it saves the result into here. So I explained this in my video, the last video I did. Now, how do we write this code? I already have the answers here. All the answers are in this document, all right, which I will expect you to go through the questions, understand. If you can write the code, I'll write the code out yourself. It makes more sense that way. So we'll just copy this code and I will explain this code to us so that this video is not too long. Okay, so the first thing is you're going to copy the name of the file they've given to you, which is 0 preprocessor. I've done this task, it's already in my directory, so I'm not doing it again. So so what do you do? Just VI and then copy the name of the file and paste it. All right, now I'm going to just VI into 0. I already have the file. Okay, I have to exit from here quickly. Okay, so I have to cd first to the directory, yes, and then here I can VI to the file, which is preprocessor. So here you can see the code which I've written already. You can see the code. Now let me explain this code. It says write a script that runs a C file through the preprocessor and save the result into another file. The C file name is this, and then it runs the C file and save it into C. Now GCC is the general command you're going to be using for running your compilation. Now when you run your compilation and it stops just after the preprocessor state, the file extension is -e. For preprocessor, for it to stop at preprocessor is -e. And then they say the output should be saved in the C, the file called C. So we use this command -o to output this to C. Remember when we were doing share redirection, input and output. So here -o is to output the results that we're going to have from this file, from compiling this file into the C file. And then you write your script constant, you save and exit. Okay, so that is for question 0. That is for question 0. So let's see question 1. Question 1 is compiler. So let me just copy this. I will say VI and paste this and enter. So this is question 1. Question 1 says write a script that compiles a C file but does not link. So it passes through the preprocessing state and then it gets to the compiler and it doesn't get to the assembly stage or the linking stage. So any file that is preprocessed and is compiled ends with a -C. But if it's just a preprocessed file, it ends with a flag -E, capital E, and this is small c. Now they say write a script that compiles a file that does not link. The C file name will be saved in the variable this. So this is the file name. The output file should be named the same as the C file. So the output file should be named the same as the C file. So we're not outputting it to any external file, but with the extension .o instead of .c. Example, if the C file is main.c, the output should be main.o. Okay. So this is our code. GCC-C and then the name of the C file. So we're not outputting it because they did not give us any file to output it to. So once you do that, you can just save and exit. Now, after saving and exit, remember for the task 0 and task 1, remember to use your execution U plus S followed by the file name. All right, followed by the file name, which is compiler. You make it executable, and then you git add, you git commit, and you git push. So that is it for question 1. Question 2, this is a file name. So I'll just say vi to 2 assembler and enter. All right. Now the question is, write a script that generates the assembly code of a C file, of a C code, and save it in an output file. The C file name will be saved in the variable this. The output file should be named the same as the C file, but with the extension .s instead of .c. Okay. So here you see that this is the assembler stage. The first question is the preprocessor. The second question is the compiler. The third question is the assembler. Like I say, for preprocessor it goes with the flag -x. Assembler goes with the flag. Preprocessor goes with the flag -e, capital E. Compiler goes with the flag -c, and then the assembler goes with the flag capital S. So this is all they want us to do. GCC, because it's an assembler, we use capital S and then the name of the file. They say the output should be the same as the C file. So this is all. Just save. Save and exit. All right, save and exit. Make it executable. Don't forget chmod u plus s and then the name of the file. Go ahead and add, commit, and push. Let's look at the next question, question 3. Write a script that compiles a file and create an executable named C is fun. The C file name will be saved in this same variable. So let's see, this is the name of the file, 3 name. Let me make this smaller. And let me just clear this. So we'll say vi 3 name and enter. So here, this is our code. So write a script that compiles a C file and create an executable named C is fun. Now, because this is how you can run your script always. So GCC and the name of the file, and then you can output it to a file if you want, or if you don't want, you can just say GCC and then the file name. For you to be able to check it, you're going to use a.out. But if you output it to a particular file, for you to check your code, you need that file to be able to check your code, because you are putting the result into this file. And to check this file, you will need to open this file to see what your result for this file is. All right, so that is the question they asked us. That write a script that compiles a C program, which is GCC, and then the file name is this, and then they say we should output it to C is fun. All right, so that is it. So save and exit. All right, then make sure you make it executable. chmod u plus s followed by the file name, git add, git commit, and git push. So here we are writing our first proper program. They say write a C program that prints. So here is a C program. Everything we've been doing is a script. Write a C program that prints exactly this, followed by a new line. use the function put. You are not allowed to use printf. Your program should end with the 0 value. So let me just open and show you guys what the code is all about. Like I said, I've written all these codes. Enter. So this is our code. All right, this is our code. Now, the first thing you do, if you have seen my video, the introduction to C programming, the first thing you do in C program is to write your header file, which is the hash include stdio for this particular function, because we have the puts, and then for the puts function is inside the stdio header. So we have other headers in C. We have stdlib, we have stduni, and other, we have std math and other headers in C. All right, so but this is a standard header that contains the put function and the print function, and and some other functions in C. So for us to write this program, we will need to import this header, which is hash include stdio.h. And after that, we'll write our comment. So this comment is because of Betty documentation, and this comment has to be written the way it is here. No white space. So when Betty complained about white space, Betty is simply saying don't use your back what's it called, your space bar while writing your code. For instance, if I try to delete this now, let me delete this. So I'm going to run Betty on this again, and you'll see what Betty is going to say, and I will explain to us what is actually happening. So if I say, so here I'm going to say main space. So you see what I'm doing? Don't just tap enter and then put your asterisk, space, main, space, hyphen, and then just put something. So I will just say this is a main function. Okay, so you don't need to do backspace, space bar to have all this in C. Betty will reject it. So always make sure there are no white spaces. So that is what is called white spaces when you have something like this and you tap enter. So by the time you come back, you find out that here, everywhere here, you see there are spaces. That is what Betty called white spaces. So the next thing I will do is to do the return, and the return, your arrow must always be capital letter. Your arrow must always be capital letter. So return, and then after the return, you use a column. Remember, for main, you use an hyphen, but for the return, you use a column. Space, you can just say always 0, which is normal programmer's language, and enter, then another asterisk followed by a / to close our comment. All right, so now we've closed our comment. So you see that immediately I close my comment, my program has returned back. So if you don't close your comment, the system will just assume that everything is a comment, so your code is not going to run. So always make sure that after writing your comment, you close your comment, something like this. Now just watch this. Every other program, okay, before I show us the Betty this thing, let's just finish, and then I'm going to put some white spaces, and just put some white spaces and see what Betty is going to tell us. Now this is the main function, which is the int main void. So this is an integer, and it's telling you that this is the main function for this program, and then the void is that this function is not saying anything. It doesn't have anything in it. All right, so it's just a void function. Now they say that we should write a C program that prints exactly this. Okay, now if you look at this code, there is a double quote here. Before programming is like building a multilingual puzzle, and here there's no double quote. And we already know that double quote is a special character in C programming. So for us to be able to write this thing, they say write a C program that prints exactly like this, followed by a new line. For us to write it like this, we will need to use the escape character, like you already know from my videos. Escape character for C programming So it's the same escape character for shell scripting, which is a backward slash. So for us to be able to write this, we're going to include a backward slash. Now in C programming, you will always have to guide your strings. So when you're writing your strings, your alphabet, you always use the quotes. If you're writing your 1, 2, 3 and numerals, you don't need these quotes. But if you are writing strings, you need this quote. If you are writing integers, you don't need these quotes. All right, so you see that we have quotes here, we have quotes here. Now for us to show this quote, which comes with the description of what we are trying to display, we need this forward slash in order for us to output this. If we don't put this forward slash, the program is not going to see this quote. It's going to assume that this is just to guide the string. All right, so this backward slash is to escape this in order for us to be able to output this. All right, now a C program, when you're writing C program, each line should always end with a semicolon, except when you are giving conditional statements. I will explain that as we go on. But each line of your code should always end with a semicolon. So you can see semicolon, you can see semicolon. Now it says that the program should end with the value 0, which is a return value 0. So that is it. Now, before I forget, you see that after your main function, you should open a bracket, and the bracket should close at the end of your program, meaning that everything you will write after your main function will be inside these curly braces. These curly braces. So once you write your main function, open your curly braces, and then make sure that after writing your program, you need to close these curly braces. Very, very important. Okay. So I said I was going to do something with the Betty so that we can see. So what I'm going to do now is that I'm going to put some white spaces. So I will just, after the 0, I will just use my space bar and give 1, 2, 3 spaces. All right. And then I'm going to save this file and exit. So now, if I run Betty on this file, Betty for put. So you see that Betty says that trailing white spaces, 1 error, 0 warning. And then the space is in line 5. The trailing white space is in line 5. So let's say our line 5. You will see that line 5 is where I purposely added those spaces. So when you see the error trailing white spaces, Betty is only trying to say that you don't need to use your space bar to give me space. If you want to give space, then use the tab key. So here I will just clean these spaces I put. So now there is no space. So if you want to give space in Betty documentation, you need to use the tab key, not your space bar. Okay, so once you see trailing white spaces, Betty will tell you the line where the white spaces are. Just go there and use your backspace to remove the spaces. All right, so now if I save and exit and run Betty again, you'll see that Betty will not have issues again. So you see, Betty doesn't have issues again because I have removed the white spaces. Now let me do something again so that you see, because I know that this Betty is really going to trouble us. Now if I come here and remove, instead of this capital R, I put small r here, then save and exit. Okay. I'm not seeing the end of my code, so I don't even know what's happening there. Okay. Okay. So let's run Betty again and see. So Betty. So you see, Betty says no description found for return value of main. And the return value of main, like you know, is that return. That's because I use small arrow instead of capital arrow. So these are things you need to put into consideration, because you are going to be meeting these things, and if you don't know these little things, you say, but I put description now. If you don't know these little things, you can spend the whole day trying to figure this out. Okay, so let me just go and make this right. So let me put back the capital R. So now Betty should be okay. So let's do Betty again and see. So Betty is okay now. Now for us to run our program, compile our program, we will need this now. So we're going to copy this. So GCC all the way to a.r, because we're not given a file to output this to. So we'll just copy that and then paste this here and say enter. Now once you enter, it's going to compile this file. If there's no error, it will compile this file for you. So you see it has compiled without errors. If there is any error in your code, it will not compile. So here you see that it's writing exactly this. You see the double quote before this. So this is how you can write this type of a program. And if you want to check your code, since it's default, you can just use $sign /a.out and enter. So here you are able to check your code, because by the time you compile your program without any output, so by output I said before is space 0 and then the name of the file. So if you don't do this, space O, well, I might say space -O and then the name of the file. So if you want to output it, you can say GCC, the name of the file says O, and then you put it wherever you want to put it. All right, but if you don't do that, the default is going to always give you is a.out. Okay, so let's go to the next question. We've spent lots of time here already. Let's go to the next question, which is printf. So for the printf question, it's a write a C program that prints exactly with proper grammar, but the outcome is a piece of art followed by a new line. Okay, I didn't explain the new line to us. I added a new line to the other one, but I didn't explain. I assume we should already know the new line character is /n. So if you have not watched my introduction to C programming, look for it and watch it. You are going to learn a lot from it. So /n is for a new line. So they say use the function printf. You are not allowed to use put. Your program should return 0. Your program should compile without warning using this. Okay, so we're just going to VI into our file. I already copied the file there. So this is our program. Now, same thing. Your header file should be included. Your Betty documentation should be included. Your main function, your curly braces, open and closing curly braces, and then the file with the program which you are asked to run. They say we should use the printf. They are not allowed to use put. You remember the last program we used put, but here we are using printf. So how do we do this now? Now we say printf and then the name of the file that we want to print. Okay, the name of the file with proper grammar, but blah blah. So you just copy that and paste. All right, copy that and paste, and then so you see, like I said, if you're writing string, you must always have your double quotes before and after all your write-up, and then with the new line command, which is /n, and then you say the program should return 0. So it returns 0 with a semicolon. So that is all they want us to do. So once you've done that, just save and exit. Okay, so like I said, I'm going to put the Google form that have all the answers to these tasks in the description of this video. So that is it for task 5. For task 6, they say write a C program that prints the size of various types of computer it is compiled and returned and run on. Now, I already wrote, in fact, we wrote exactly something like this in my introduction to C programming. So you want to go and check that out too. All right, exactly the same thing, exactly the same thing. All right, I show us how to write for, how to check the size of an int, the size of float, the size of string and all that in your computer. Either you're using 64-bit or 32-bit, you can check it using the size of command. All right, so let's vi into our file. Sorry. So I'll just say vi and then the name of the file that they've given onto us. Now this is my C program. Okay, so I'm just going to explain this briefly to us. Now, in our program, let me before the program, so you see they say that you should produce the exact same output as in the example. This is the example. This is the example. So size of a char and then the column with your program. Size of an int, size of a long int, size of long int, size of a float and all that. So let me open our program so that you see. All right. Now, you see that we have our header, we have our Betty documentation, the main function, and then the curly braces. Like I say, this is always a constant. You can't hide. Now, before we continue to write our program, we need to declare our variables we want to use. So char A, which is for a character, which is a single character, integer, long int, long int, and a float. Okay? And then we're using the printf function to write. So this size of a char is already what they've given us from the question. Size of a char, size of an int, size of a long int, size of a long int, and size of a float is already given. Yeah? So we just write the text, size of a char, and then with the column, and we say the specifier. So we say percentage LU byte, then with a new line, unsigned int, unsigned long, size of A, because we declare A for a char. For B, for int, we declare B, which is size of int. All right, so this is how you can write this program with the help of this size of command. So once you are done, put your return statement, which is 0, and then save and exit. So I'm not explaining too much because I did exactly the same thing in that video. So you can go and watch an introduction to C programming. Then question 7 says, write a script that generates the assembly code inter syntax, okay, of a code and save it in an output file. The C file name will be saved in the variable this. The output file should be the same name, so we're not outputting it to anything. And then example, if the C file is okay. So now, just before I forget, you need to, when you are done writing this your program, so you just type gcc space the name of the file, which is this, and then enter to compile the file, because before you add, before you commit, and before you push. Okay, so let me open this file. This is the advanced task, so let me open this file. Okay, so you see this program, it says we should write a script. So this is a script, not a C program. Write a script, the C file, blah, blah, blah. So now, we're using GCC, and then -s, you should already know what -s is assembly. Why are we using assembly? Because they say generate the assembly code. So we're using -s, capital S. And then this MASM is a syntax of inter syntax. So you can just check for inter syntax in C and you see this. So this is an inter syntax. All right. And then the name of the file which is C file, and they didn't give us an output, so we just ended it because the output they say it should be the same with the name of the file. So you can just do that, save and exit. Okay, and when you do that, please, because this is a script, remember to make it executable, then add, commit, and push. So for the last task for this vi, let's see the task. Okay, for the last task, it says that we should write a C program that prints exactly, and that piece of art is useful. All right, you should write this followed by a new line. Of course, you know the new line, which is /n this. All right, and you are not allowed to use any function listed in the name section of the man3 printf or man3 put. So you can check that out, the manual printf, and then you can also check the manual for put. Your program should return 1. Return 1, no longer 0. Your program should compile without any warning. All right. So this simply is our code. Now, if you look, because they say you are not allowed to use any function listed in the name section of the man, we cannot use the printf function, we cannot use the put function to print this. Why? Because this printf and put are in the man function for 3, which is the stdio.h. So we have to import another header, which is uni_std.h, and then we use the write function rather than using printf or using put to write our program. All right, so once you do that, you can just quickly save and exit. And once you save and exit, go ahead and compile your file. Go ahead and compile your file. So you can use this. They've given us what to compile with. GCC, use this all the way down to here. So there's an output here. This is an output for this. So you can just copy this, paste to compile your file. Then once you've compiled, no errors, you can then go ahead to save, to push to GitHub and check your code. Now, before I forget, for each C file you code, always make sure you do Betty first. So Betty space the name of the file. Betty space the name of the file. Check. If Betty doesn't give you errors, then you can go ahead and compile your program. So always make sure that you have your Betty documentation checked first before you can run your program. If not, the checker will give you errors. Your program will compile, but checker will still give you errors. All right. So we've come to the end of today's video. This task, the Hello World C programming task. Thank you for joining. Make sure to leave a comment if you enjoyed this video. Give us a thumbs up, share our videos, and see you again in our next task. God bless you.